In my last video, we determined the shape we needed for our beam. It was a W12 by 26. So in SolidWorks, we can fairly quickly get the sketch needed for that shape and extrude it and then do our simulation by using having our simulation tab, which if you don't have that open, you're going to probably need to come to the SolidWorks add-ins tab, click on SolidWorks simulation. That should bring up this tab. And then another thing we're going to want is the SolidWorks toolbox, which actually all that does is add this section here at the end of the SolidWorks add-ins tab. So we're going to start here, and we're going to click on this structural steel button. And that will bring up this dialog box, which it might start on the C channel or whatever, and then come down to W beam, and then find the beam that we had determined in our calculations, which was a W12 by 26. There it is. And then we'll hit create. And that should put a beam in here. For whatever reason, it just plops it in under defined in a random spot. So we'll just jump in there, edit the sketch, and get that kind of fully defined. Not sure why that didn't give me midpoint. There we go, midpoint. And also dragging on it, it shows me that it's not defined that way. So I'm going to put a horizontal on it. And now we're good to go. I'll exit the sketch. And then I already had set this up. So I have my profile. And now I have this sketch 2 here, which actually I need to fix this up. I'm going to reference this sketch here. Coincident. Now that's my length of my beam. So 18 times 12, 216. And with that done, this step here I'm about to do is going to be useful. We don't really need to do it for this one, but if you had 2 different distributed loads on the beam, you're going to want to split that into sections so we can apply those weights to those different parts of the beam. So what I'm going to do is select sketch 3 and click on the wrong thing. And then I'm going to close that and come back to features. I'm going to hit extrude. And I'm going to go from vertex. I'm going to click the end of the beam reference. And then direction, I'm going to go up to vertex and click there. For some reason, it won't let you. Let me try that one more time. It won't let. No, I guess it does. Okay. It was giving me issues where it wouldn't let me pick a point, but it just did there. So that's good. Hit check. Select my sketch again. By dropping it down, get into sketch 3, hit extrude. Do the same thing, vertex. Maybe it's this one that was. Yeah, for whatever reason I can't select a point for my vertex, but I can click the one on the sketch. That's silly. Okay, up to vertex, 0.4. Make sure to uncheck merge result. And then one more time, I'm going to go up to vertex or from vertex, click there, up to vertex, and right there. Uncheck merge result. Now I have 3 sections of the beam. So like I said, that's only really necessary when you have a distributed load, say 5 feet in, and then the rest of it's, so that 5 foot is 10 or 100 pounds per linear foot, and then the rest of it's 500 pounds per linear foot. So you can apply those different distributed loads to those sections. You can kind of split them up like I did here. So now with everything in place, when you have your concentrated load, you're going to want to put these points on here. I have those points referenced off of this length sketch I did. So I put points where I needed them, went into reference geometry, clicked on point, selected those points from that sketch. So now I should be good to go into simulation, new study, name it whatever, we'll just call it static, and then hit check. All right, the first step, you're going to take example 1, right click, apply material. We're using the A36 steel, so it's right here underneath the steel folder, A36, hit apply, close. Now this is I don't know why they don't let you just do this from the overall folder there, but you're going to have to go right click on each of these and say treat as beam. Treat as beam. And double click on it too many times. Okay, there we go. So those are all beams. That gives me my joint groups. So that will allow me to, on my fixtures, right click, fix geometry. And these are where the beam is supported. So I'm going to select either end, hit check. And now I need to apply my loads. So right click on this, go to force, and select the points of where my concentrated loads are going to be. I need to select the direction. So in this case, I just want the plane that's going to be almost collinear or parallel to the forces. So we'll select the right plane. And then our force will be going downward. We'll flip it, and it's 8,000 pounds. I'll be providing a template for this, so a lot of this stuff will already be set up, but the units and all that, if the template works out, just change that. Oh, yeah, be careful with pressing enter when doing this. For whatever reason, it doesn't like that. Oops. So if I press enter now, it's going to revert back to what it was, and that's just SolidWorks being kind of stupid. So just click somewhere else or hit check. So that's good for those. And then I need it for the distributed load, so I'm going to put force. So for your distributed, you'll click on beams, select the sections, once again the direction, so the right plane. You can do per unit length or just leave it there and calculate what the weight would be, which we had at, what was that? That was, where's that at? Right there. 72, but there's 3 sections now, so I got to divide that 7,200 by 3. And then reverse direction. And now with all those in there, I can right click up here and click on run, or up here and run this study. So run. And the main thing we're looking for when we do this, and I'll show you a couple extra things, is that our stress here is below our allowable. So our allowable was 24,000 psi, and this comes in at 23,000 psi. So this will work for what we're dealing with. So a couple other things you can do with this is get your shear diagram and moment diagram. So if we right click on the results here and click on list beam forces, and that popped it up there. That's not what I wanted, sorry. I want to right click and I want to do define beam diagrams. And I'm going to do shear force direction 1 in pounds. If your result isn't what you think it should be, try doing in direction 2. I've jumped back and forth to figure out why you kind of get different results because of the direction, and I haven't quite pinpointed what causes it, but it's a quick process of just jumping to the other one to see if you get the results you were actually looking for. If you don't get them on either, that just means that you had done something wrong. Chart options, this should all be part of the template I send over. I left it as floating, so otherwise you got scientific if you prefer reading it that way, and a couple other things I've checked, but that should be part of the template I send out. And then I'll hit check. And you can see that those are the reactions that we had and what the shear diagram would have looked like. And then to do a moment, same process, define beam diagrams and pounds. I want to say that I'm going to make sure that my template, you don't have to change that each time. Then I'm actually going to try this in direction 2, because last time I did this, it didn't show up until I did in direction 2. Everything else should be good. SolidWorks does this in pounds per inch, so that's a good reason why you want to just convert those to pounds per inch, or inch pounds, or whatever you want to say it. Hit check, and you can see here that our maximum matches up. And then the last thing, if you want to do this, you can also make a report. So actually make a Word document of all the different preferences you want for it. Hit publish, and you'll have the diagrams and a couple other details on that report. I'm not really going to require that, but it's just something there if you want to play with it. So the main reason to do this is, as you're going through your problems, you can jump in here and make sure that you had selected the right beam. And the biggest thing you're going to pay attention to is, with this, is your stress. If this number here is greater than 24,000 psi, which I think every problem is using the A36 steel, so every single one of them should have that 24,000 psi. If it's much greater than this, then you know you've selected the wrong shape. So if you have any troubles with this or can't get it up and running, obviously contact me through Slack or any other way you want to, but Slack's probably the quickest way to get a hold of me.